Hello, I'm Manohar. I'm gonna show you what all activities we have done for final data mining project. So we have used the Korea data. Uh, we have the data for the 5 stores, and then the data talks about the sales. So we have the aggregated sales data according to the date, and then we have the data for 5 stores. So we have the variables called distances from different stations, and then we have the some flag variables like holiday, and then we have categorical variables like output, and then we have the details about the Japanese tourists which have visited the Korean stores. So as we can see, there are 5 different stores. Every store has different behavior and pattern hidden in their variables. So we thought it will be good idea to split the data as per the stores. Every store has the different sets of variables which can be important to predict the total sales. So we have thought to segregate the stores in different files. So we will be analyzing the data store wise. So let's see the procedures which we have followed in the SAS Enterprise Miner. To build the models, we have used the SAS Enterprise Miner. As you can see, we have loaded the data using file import node. So we are predicting the total sales. So this will be our target variable. And then as you can see, we have rejected the variables called average sales per customer and average sales per item, because these variables got derived using from total sales. So to build a good predictive models, we have to remove the dependencies. So we have rejected all these variables. Then we could see lot of variables and missing values in the data. So the impute function has been applied on the data. So I have kept the missing cutoff as 50%, and the procedure to populate the variable and the data, I have used the mean. So you can see like the 251 missing values have been populated using mean procedure. To understand the skewness of the data, there is a transform variable node. So this screen shows the distribution of the each and every variable. So we can see the actual high temperature and all these variables, they are normally distributed. So looking at the data, we can see the discount is highly skewed. So to remove the skewness, we have used the logarithmic values and the conversion on the discount data. So after applying the logarithmic conversion on the discount, we got the distribution as below. So uh, we have done the log transformations on discount variable. So these were the basic pre-processing steps which we have applied on each and every store data. So now let us look at the exploratory data analysis on the store data and store variables. We have the aggregated sales data on daily basis. So we all thought that it will be good if to analyze the data using time series. So I have created the time series model for the data, and then I have loaded the data, and as the time series does not work on the categorical information, so I have rejected all the categorical data which we had. So Outlook, store name, and the weekday I have rejected. The same pre-processing steps have been applied on the data as we have seen before, and then the final output I got it from the time series using TS data preparation node. So in the property tab, I have transposed the data according to the time ID. So it will have the information about the day. This is the output window of the time series preparation node, and then this is the time series for the total sales distribution according to the dates. So we can see the deep glitch from March till July. So this was quite interesting to analyze what was happened in these 3 months. So when we saw the data and when we looked at the comment section, we got to know the ownership for the store A has been changed. So to analyze the data and again to keep the important variables apart, we have made the two partition in store A. So we made the store A1, which will be for the data before ownership has got changed, and the store A2, which will be for the data after ownership. And then we will be comparing the variables between store A1 and store A2. We have loaded the store A1 data, which is the data before ownership has changed. And we have applied the same pre-processing steps on the data. To conduct some more exploratory analytics, we have used the Stat Explorer node and then multiplot node. This is the result window of multiplot node. So we can see the histogram which talks about the weekday versus total sales. So we can see here that on the Saturday and Sunday we usually have got more sales if we talk about the store A1. Then we have the similar other plots which we can use. So maybe we can use the discounted amounts. So we can see we have got the total sales. We have seen that the maximum total sales we got when we have provided maximum discounts. To understand the statistical information and the skewness about the variables, we have used the Stat Explorer tab. This is the Stat Explorer node window, and then we can see the statistics of each and every variable in the output node. So it talks about the standard deviation, missing, non-missing variables, and then minimum, median, maximum, and skewness and other statistics. So to understand the significant variables for the store A1, which is before ownership, I have executed the variable selection node on the data. So this is the output of the variable selection node. And we can see that the number of customers, weekday, month, and year were quite significant to predict the total sales for store A1, which is before ownership. And these are the good predictors because their p-values are less than 0.05, which is the critical value. The pictorial information about the worth of the variables can be shown in the histograms. So this histogram talks about the significance. So as number of customers is quite significant than weekday and month and year. So this is the pictorial representation. To compare the data with store A2, which is after ownership, I have loaded the file uh, of store A2 data, and I have used the same pre-processing steps on the store A2 data. Let us see what all variables we have got using the variable selection. This is the output window for store A2, which is after ownership. In the output window, we can see the predictors are changed, though some predictors are same. The predictors like holiday, outlook, and log discount played important role to predict the target sales. So we can clearly see the change in the predictors and the significant variables before ownership and after ownership. So after all pre-processing and data exploration steps, we have built the model on the data. We have chosen regression models, decision tree, and the neural network. So we have partitioned the data in 40, 30, 30, that is 40% training, 30% validation, and 30% test data. So to understand the difference and the trend between different models, we have used the model comparison node, which shows the trend between all these models with the statistics. This is the result window of a model comparison node. So to understand some statistics, we'll look on the output screen. So we can see that on the trained data, the average squared error is minimum for the tree, and then on validation data, the average squared error is also minimum for the tree, and even for the test data, the average squared error is minimum for the tree. So as compared to the neural network and the regression models. So decision tree worked best for this particular data set, which is before ownership. These all are the statistics. So to better understand the trend, we will see some graphical information. This is the graphical representation of a model comparison node to understand the trend between the different models. So for the training data, all the three models almost worked well. And for the test data, we can see specifically decision tree worked well because the red line shows the actual target values and blue line shows the predicted values. So for the decision tree, both lines are pretty much same, but for neural network and regression trees, the lines are comparatively different. So decision tree worked well for the data before ownership. Similarly, we have executed the same models on each and every store's information which we have, but due to time constraint, we cannot show the results of each and every store. So for every stores, we have got some different significant variables to predict the output results. Thank you.